Kia ora Year 11 and 12. Here's another of the algebra questions from yesterday's exam. So again, this is mainly made for next year's Year 11s and 12s who are doing level 2, because those of you who've just sat the exam might still be in recovery mode. Okay, so this question is one where we have to show that the graph of this function crosses the x-axis at two distinct points. So as soon as you see that, you should be thinking that it's a discriminant problem. Now we know that this is a quadratic, and it's an up the right way quadratic. So for two distinct points, we're looking at something like this, one of these situations. And so we need to show that the discriminant must be strictly positive. Not greater than or equal to 0, but actually strictly greater than 0. So the discriminant is b squared minus 4ac. What we need to do is to expand this out and then figure out what the a, b and c for the discriminant are. So y is equal to this. So it's a factorised quadratic with a bit stuck on the end. So minus c squared. So expanding that out gives me this x squared minus ax minus bx plus ab minus c squared. Collecting up the like terms to get the coefficients gives me this. So now my discriminant, which I'm going to write as b squared minus 4ac in inverted commas, because the b, the a and the c in here obviously are the coefficients here. They're not the a, b and c in the question. So the b squared minus 4ac here is equal to this. Minus 4 times 1 times the constant, which is this. And if I expand that, we get a squared plus 2ab plus b squared minus 4ab plus 4c squared. Collecting up the like terms, hopefully you'll see something nice happening here, gives me this plus 4c squared. And we should spot this as being a perfect square. So this gives me a minus b squared plus c squared. But now we need to explain how do we know that that's always positive. So you could do it like this. So since c is not equal to 0, oh, I've lost a 4 in there. That's 4c squared. Since c is not equal to 0, c squared is always going to be positive. So 4c squared is strictly positive. And we know that a minus b squared can't be negative. It might be 0 if a and b are equal though, so we'll make it greater than or equal to. So what does that mean? Well, that means that the discriminant, which is this, must be strictly greater than 0, and that's what we needed to show. So there you go. I think that question is much more kind of seeable than the one I videoed before, which was 2e. Okay, so it's basically an application of what you know about the discriminant. So hopefully that one went reasonably well. Thanks for watching. I'll do some more later on tonight.